Kelly. I wanted to make you a U substitution video like we talked about and try to explain kind of more detailed why certain things are happening. So I just went to the textbook and pulled out one from the section that has a whole bunch of U substitution problems on there. So anyway, the original problem is this one right here. So I hope that made it clear when doing these problems. You always go to this middle term, and this guy is going to be your u. So u is going to equal x to the 1/2 for our problem. And I wrote off in parentheses that it's always the middle term minus the coefficient. So you won't use the 3 or, whatever it may be in front of it. So strictly the x to the 1/2. The reason behind doing this is because we are going to rewrite this as a quadratic equation because we have all of those ways that we can solve a quadratic equation. We first check factoring, like we talked about earlier, quadratic formula is always an option. So we have lots of ways to solve quadratic equations, and like I said, quadratic formula works on all of them. So we will, if we want to solve for x, it's got to be in a way that we can do it, and we haven't learned about how to solve something like this. So we're going to rewrite it as a quadratic equation. So the way that we do that is create this u value to allow us to rewrite this as a quadratic. So with that in mind, our first term, instead of being x, is going to be u squared. So what I did is I came off to the side up here and I wrote u squared, and I swapped the u for x to the 1/2, which is what we decided it was going to be. And since it's u squared, I took our u and I squared it to show you that when you square our identified u value, you're gonna get an x. So I wrote out here, we have a power to a power. The 1/2 is a power, squared is another power. So 1/2 times 2, because that's the rule of exponents, that when you have a power to a power, you multiply. So I did 1/2 times 2, in other words 2 over 1. I multiplied across and got 2 over 2, which is 1. So I'm showing you in all of this that u squared is actually x to the first power, which is what this is, okay? We're just writing it differently, okay? And then we have our plus sign from our original equation, 3u, because we did x to the 1/2 was a u, so simply swap that for u, minus 4 equals 0. Then we factor this quadratic equation because now it is absolutely a quadratic equation, okay? Put your -4 in the bottom, your 3 in the top, multiply to get the -4 while adding to get the +3. You have a -1 and a 4 that does that. So your factors are u minus 1 followed by u plus 4. You break those two factors off, you set them equal to 0 to solve for u. You end up with these two options for u. You then swap the u for the x to the 1/2 that we, substituted it for. And to make this exponent a 1 like we want it to be, because we just want it to be x, or x to the first power, you have to square both sides. Because like we showed up here, 1/2 squared gives you an exponent of 1. So you see me squaring both sides. 1 squared is 1, so there's one potential solution of +1. Again, you see me squaring both sides. -4 squared, -4 times -4 is +16. These fractional exponents are also called rational exponents because they connect to radicals. Like when you have the 1/2 power, it's the same thing as the square root. So x to the 1/2 is equal to the square root of x, okay? Anyway, so because we are basically dealing with radicals, I went ahead and checked both solutions because a lot of times radicals don't allow both solutions to work. So I took my 1 back to the original equation and did the x plus 3x to the 1/2 minus 4 to see if I got 0. And I did. Remember, the 1/2 power is like the square root. Well, the square root of 1 is 1, okay? So 1 plus 3 is 4. 4 minus 4 is 0. When I did the 16 in place of x, the equation, remember, was x plus 3x to the 1/2 minus 4. So x plus 3x to the 1/2 minus 4. So x is 16. X is 16 to the 1/2. Square root of 16 is where I get the 4. So 3 times 4 is 12. So 16 plus 12 minus 4. 16 plus 12 is 28. 28 minus 4 is not 0. So this one didn't work.